Good morning, students. I am going to start a remaining part of the topic energy. In the first part of the video, I have discussed the concept of energy and its definition, SI unit, as well as different forms of energy. In case you missed that video, please see it before to watch this video for your better understanding. Now let us discuss the law of conservation of energy. Law of conservation of energy holds during the transformation of energy. The law of conservation of energy states that energy neither be created nor be destroyed, it only can be converted from one form to another. The total amount of energy is always conserved. Sun provides light energy and green plants synthesize the food by converting light energy into chemical energy. When food is eaten by animals, the food entered into the stomach and gets digested to convert into glucose. Here I am talking about carbohydrates that further oxidizes in the cell of the body to provide heat energy in the form of ATP. So, chemical energy has been converted into heat energy. Now let us see the interconversion of energy from one form to another. Television, we are giving input as electrical energy and we are getting output as light and sound energy. So, I can say television converts electrical energy into light and sound energy. Similarly, electromagnet converts electrical energy into magnetic energy. Speaker converts electrical energy into sound energy, and microphone converts sound energy into electrical energy. Dear students, just to see the difference between speaker and microphone, the energy conversion is different. Suppose now you are using a mobile phone, the place where you listen that has got a speaker that converts electrical energy into sound energy, and the place where you speak that converts sound energy into electrical energy. So it consists of a microphone. Your electric motor converts electrical energy into mechanical energy. Electric heater converts electrical energy into heat energy. Solar cells converts light energy into electrical energy, or even you can say solar energy into electrical energy. Battery during charging, when you charge the battery, maybe inverter battery, maybe your mobile battery, it converts electrical energy into chemical energy. When you are using, that is called discharge of battery, it converts chemical energy into electrical energy. Let us understand this phenomenon by taking few examples. At first we are going to observe that how the energy not only conserved but also converted in hydroelectric power plant. A typical diagram of hydroelectric power plant is on your screen. Carefully observe. The area of the figure marked A denotes as reservoir of water, B denotes the flow of water through a narrow channel, C denotes a turbine, and D denotes the dynamo or generator. When the water stored in the reservoir, the water is at rest, so it possesses energy is called potential energy. In B, water is allowed to flow through a narrow channel, so the potential energy converted to kinetic energy, which rotates the turbine at C. It means the translational kinetic energy converted into rotational kinetic energy. The turbine is fitted with an axle attached to copper coil placed in a strong magnetic field, that is your generator or dynamo at D, which converts mechanical energy into electrical energy. You may have a question here that is the entire 100% potential energy of water converted into electrical energy? Regarding this, you have to be little more mature to understand the dissipation of energy, which you will be learning in the next higher classes. Now let us see how is energy conserved during the oscillation of a simple pendulum. The position A and B is called extreme position and the point M is called mean position. I think this is very conspicuous to you from the screen in front of you. At both the extreme position, the energy possessed by the pendulum is only potential energy but no kinetic energy, whereas at M, I mean at the mean position, only kinetic energy but no potential energy. The total energy possessed by the pendulum, irrespective of the position A or B or M, is the sum total of potential and kinetic energy that remains constant. Now you may have a question that what happens when pendulum is in between A and M or between M and B. No doubt, at any point in between A and M or in between M and B, the energy possessed by the simple pendulum is both potential and kinetic energy, but the sum total of energy remains at constant. It means, in the nutshell, I am going to say that when pendulum moves from M to A or M to B, the kinetic energy slowly decreases, and at the same time the lost kinetic energy converted into potential energy. Similarly, when the pendulum moves from A to M or B to M, the potential energy slowly decreases, and at the same time the lost potential energy converted into kinetic energy. Hence, the total energy is always conserved, subjected to a condition that no energy dissipated or lost to the atmosphere or surrounding. Now let us see how is the energy conserved during a roller coaster ride. Carefully observe the diagram in front of your screen. At the left bottom corner is a electric motor which enables to start the roller coaster and pushes the cars of the ride to the top. Now tell me what energy conversion taken place here. No doubt, at the top point above the ground, the energy possessed is potential energy. So we can say that the electric motor converted electrical energy into mechanical energy, that is the kinetic energy pushes the car, and at the top of the whole kinetic energy converted into potential energy. When the car descends, they lose the height from the level ground. So potential energy slowly decreases and kinetic energy slowly increases by converting potential energy into kinetic energy. So when the car moves down, the potential energy converted into kinetic energy, and when the car moves upwards, the kinetic energy gets converted into potential energy. The total potential energy and kinetic energy remains at constant. Hence, the energy is conserved. In this case, if you want to learn extra, that is your plus plus, then think what is the form of dissipation of energy. Yes, that is your friction, heat as well as sound. Dear children, you have got some assignment. Learn page number 29 to 32. In my next video, I will be discussing the exercise questions and answers. So before that, I would request you extract some important answers as well as important points from the exercise. Thank you for watching this video. Please do not forget to like the video.